recording. All right. So, our first one is f of x is equal to 5x minus 1. Okay. Let's do kind of this notation. F prime of x here is just 5. This is just a polynomial with two terms, right? A polynomial is sort of going to have something out front. It's going to have a kind of x term, and then it's going to have a nice whole number, a 2, a 3, a 1. Here, example is 1. But if this was ax to the power of 2, the a was 5, let's say, then we would do 5 times, we would bring the 2 down front to be a multiplier, and then the x, and we would only have 1 here, we would reduce our power by 1. Okay? So that's the trick for polynomials. If you're here, you probably already know the trick for polynomials. So let's kind of keep moving forward. Yeah? Our constant, really, we could write that as 1 times x to the 0, because x to the 0 is 1, right? And then we bring the exponent down, and what happens? The whole thing becomes 0, right? So it's 5 plus 0, or just 5. All right, not bad. Let's jump to number 2. So f of x is equal to negative 4 x to the 10. Okay, so here's a good example. What we're going to do is we're going to take the exponent, it's going to become something 1 less, and that 10 will come down as a multiplier, and the negative 4 is still there. So negative 40x to the 9 is our f prime of x. Okay. Boom. Is there a better spot I can put this? I think there is. Maybe I could do this. Okay, that actually I like. Okay, let's do it. Number 3. So okay, now we're given kind of a more fleshed out polynomial. Polynomials have these terms that have a constant. They have an x or some variable with a whole number exponent, and we're going to have a sort of like, ax to the something plus or minus another kind of bx to the something plus or minus a cx to the something plus or minus, and we can keep going forever, right? And the rule for each term is always the same. So let's do it. F prime of x, is the music too loud? 2x plus 3, and the 3x becomes 3, and the minus 4 doesn't have, or its derivative is 0. Okay, let's do number 4. Let's get it, let's get it. Okay, number 4 is, these are all f of x's, which is not good. It's like writing a story and naming all of your main characters Ali. It's possible, but why do that? Okay, so another thing, we're just going to do each term. This is called a term, right? Each term has a coefficient, the number out front. It has a variable part, the x to the 8. The rule is that's going to go down by 1, and the 8 is going to come down out front as a multiplier, and the 5 is still there the whole time, right? So really it's 40x to the 7 minus, and if we do it here, 10x to the 4, and that's it, because our 6 doesn't have a derivative, or its derivative is 0. Whoa, 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 okay. Boom. Okay. Let's do it. That's 1 to 4 down, right? Okay. Let's go to 5. Let's maybe do this. Make this a tiny bit smaller. Let's make that a true statement. And yeah, let's do it. Let's jump to 5. Okay, 5 is what? 1 quarter t to the 4 plus 8, mate. All right, let's do it. So the fact that this quarter is there doesn't really affect how we're going to do this. It is not a polynomial, so let's maybe turn it into a polynomial. We're just going to sort of get a t, oh, t to the 4 over 4 plus 2, right? Okay, well now let's take the derivative, and we get 4 out front over 4, and then t to the 3 plus, well, 2 doesn't have a derivative, so it's just that, or its derivative is 0, right? So, okay, not bad. We're getting there, right? Okay. 6. All right, finally, we get some new names in here. Some fresh air. 1 over 2. Oh, that should have been an f of t as well. How embarrassing. Is it more embarrassing than I just did that? Okay, boom. F of t is a quarter t to the 6 minus 3t to the 4 plus 1. So I'm just going to go right into it. We're just going to get 3t to the 5 minus 12t to the 3, and that's it. Bada boom, bada bing, maybe. It's getting too easy. All right, that's 6 done for you, right before your very eyes. All right, let's do it. 7 is y is equal to x to the negative 2 over 5. Okay, let's do it. So the rule is the same, right? Y prime is going to be negative 2 over 5 x. Now we have to subtract 1 from that, right? Is the rule. When we take the derivative, we take the constant exponent, we subtract 1. So that's actually going to be minus 7 over 5 now. But there it is. Same rule, right? Boom. Dunzo. Okay. 8. Come on, let's get some pretty 8s up in here. Better. Okay. Y is equal to 5e to the x plus 3. Okay, so this is our natural number e. This is the first time we've seen x in the exponent. Okay, so what we get, and we could prove this using, of course, we could prove all of these using limit definitions, but all of these sort of turn into just rules that we memorize. The derivative of e to the x is actually, with respect to x, is actually just e to the x. Okay, but there's a hidden thing happening here, which is that there could be a function in that exponent, and the function would still be there, but then we would also have to multiply, because of chain rule, by the derivative of f of x, or, you know, d f of x dx, right? So if there's a function in the exponent, or if it's not just plain old x, because the derivative of x is 1, so that's convenient. But if it's not, then we have to take the derivative of that exponent. Okay. So that is our e to the f function. So here it really just becomes 5e to the x. And the 3 is like any other term that we would do over here, right? It doesn't show up. So, okay. keep it going. All right. So, ooh, V of R. For some reason, I picture this as, you know, Germanic, this function. Ooh, okay. So pi is a constant. It's just instead of a 4 using the symbol 4 to represent a constant number, we use the symbol pi to represent a constant number, right? It's a little bit of a uglier number, but that's just your subjective view of things. So 4 pi over 3 is another way to write that, is just the constant out front. That gets multiplied by 3, which turns out into just 4 pi because the 3's cancel, right? And then r is the variable here. So that thing, the rule is gets reduced by 1, right? Okay, let's keep it going. That's 9, 10. I think after this one, get a little drink of water, have a little tangerine. But let's do it. So r of t, okay. I don't know what I picture for this function. Maybe an avid reader, I think. Am I just like that simple? Am I a simpleton? That it's just the letter that starts with? Okay. So r prime of t is the child, right? Disappointingly so, not so much of a reader. Okay. But they do listen to audiobooks, so. Okay, so 5 times -3, right? Over 5, we'll just cancel the 5, so we'll just get -3, and then the t, so that, sorry, that should be a factor out front, that has to be subtracted by 1, so we just get -8 over 5, right? Boom. Okay. Let's do it. 11. Oh wait, did I say I was going to take a little drink of water? Okay, let me mute, just get a drink of water here. Okay. Before we start 11 here, I'm just going to peel the tangerine. You will not get the ASMR unless you want it. Unless it's called for in the chat. Alright. Tangerine is peeled. Slices at the ready. Oh, my hands are all wet. Okay, let's do it. Another grind. Okay, we'll take a proper break at 20. Where are we here? Let's do it. Y of t. Okay, this is starting to get repetitive, so hopefully things get a little bit more complex here. Oh wait, you know what? That's it for this one. Um, let's do some of these. Okay, so this is where our chain rule gets introduced. So let's do. Ooh, we didn't really see any. We didn't really see any quotients, right? So let's maybe do that first. So let's do f of t is equal to 2t over 4 plus t squared. Okay, so this is a quotient. Now what I would recommend is actually treating this like a product, okay? So we have the division of two functions, so we're going to have to do something with the fact that there's a division there and do the the derivative of that division somehow, and then we'll also have the functions on the inside, because you'll probably be able to tell the derivative of the top is 2, the derivative of the bottom is 2t, but you don't just take the derivative of the top and divide it by the derivative of the bottom, right? It doesn't work out that way. So let's actually do 2t. Let's sort of say that this same thing, f of t, is equal to 2t times 4 plus t to the power of 2 times negative 1. Okay. Now I'm going to do chain rule. Now this is kind of like the outside, right? This is the function on the outside. And what would be the derivative of that? Well, it would be bring the negative 1 out front, and this would go down to negative 2, right? So let's kind of do that on the outside and then take the derivative of the inside. So this is the chain rule, that we can kind of get away with this outside-inside trickery. Yeah? Okay, so let's keep it going. So, and product rule, we could show this, but this is maybe something that belongs somewhere else, not necessarily in the challenge. But, when we have u times v, the derivative of that, we will get u prime times v plus v prime times u. Okay, so you kind of take the derivative of each and keep the other original, right? And add them together. Okay, so let's do that. So what that means is this, let's not use blue there. This here is our first thing. This here is our second thing, right? So the derivative of the first thing, remember, it's u prime v plus v prime u, right? If this is u times v. So u prime, what is u prime? It's just 2 times v. So we have to keep that original, that whole thing. And then plus, okay, not bad, we're already halfway there. Plus v prime. Now that's the ugly one, but do we agree that there's going to be at least a 2t there? Now the derivative of this is the derivative of the outside times the derivative of the inside. So we get a negative 1 times a 4 plus t squared minus 2. That's the derivative of the outside. Now the derivative of the inside is 2t, right? And you'll notice that that thing we can kind of factor out of both of them, right? So if we wanted to sort of simplify this, we would factor everything. We could take a 2 out as well. You'll notice we can kind of like bring some 2t's times 2t's together. This actually isn't plus because there's a negative 1 in there. So let's make it kind of like a little more fair representation. Let's say 2 over 4 plus t squared. That's what this term is, this whole term. And in fact, that is found in this one as well. So let's just say 1 plus, and what happens when I factor it out of this one? That one of those goes away and the 2 goes away, right? So what are we left with? We're left with minus t squared up top. I think actually 2t squared, because that 2 sticks around even though we got rid of the other one. So minus 2t squared over 4 plus 2 squared. And we could maybe keep it there. That's pretty nice, right? Okay, so that one is, it's a little sloppier, it's a little nastier, but that's just the way it goes. And we were kind of showing product rule in a quotient, right? So, it's kind of the way it goes. Okay, so let's do it. Let's put that in its home here. Um, Is this maybe the best way to do this? Let's maybe do this. Okay, a little bit of a crazy start to whatever the S song is. Let's do some rearranging here. All right. Actually, don't like this. Okay. So let's do it. 12, right? So what was 12? Okay, so 12 is v of x is equal to 2x cubed plus 3 x to the 4 minus 2x. Okay, so let's do this as a product rule, right? So let's say v prime of x. This is going to be our first and our second, right? And then we'll do derivative of the first times the second plus derivative of the second times the first, right? So let's, and then we can even kind of do this, right? Let's do that. So that plus that, but in the first circumstance, we're going to take, so we're going to sort of keep that original, but we're going to take the derivative of the first one. So what's the derivative of that? It's really just 6x squared, right? And then in this one, we're going to keep the first one, and we're going to take the derivative of the second one. So what's the derivative of that? It should just be 4x to the 3 minus 2, right? And now that can all be kind of simplified. So let's just kind of follow through on that. We can say 6x to the 6 minus 12x to the 3 plus, and now this one will have to expand. Can we do anything to simplify? I don't think so, right? So let's just kind of do it. So, ooh, what do we get? Okay, so we're foiling, right? We can't even bring any 2's or anything out. Okay, so 8x to the 6 plus 12x to the 3 minus 4x to the 3 minus 6, right? Okay, so let's kind of bring all the x to the 6's together, right? So that's 14x to the 6, and then all the x to the 3's together, so the plus 12, the minus 12, so we're just left with the minus 4x to the 3, and then we have minus 6. So we can kind of take a 2 out, but why bother? That's our derivative, baby. Not bad. Okay, pretty tough one. We're getting tough. We're getting tough. Tough on crime. Okay, 13. What is 13? 13 here is u to the minus 2 plus u to the minus 3. Uh-oh. Times u to the 3 minus 2u to the 2. Okay, so it doesn't matter that it's now a different variable by a different name. We're going to kind of treat it the same way. And honestly, I might factor out some things first, right? Because I could probably get an u to the 2 out of both of those, and I could get a u to the 2 out of both of those, right? And one of them would be negative 2, one of them positive 2, so maybe they cancel, right? So I'm actually going to do some rearranging first. I'm going to say u to the minus 2, factor that out. I get 1 plus, now let's be careful about this, that divided by u to the minus 2 is u to the minus 1, right? So then u to the minus 1. And out front of this one, we can get u to the 2, right? And we get u minus 2, right? So what a surprise, those u to the 2, u to the minus 2, they cancel. this gets a lot simpler. We still kind of have to do this, but let's even maybe just turn this into a quadratic, really fully learn the lesson here, because something's going to be nice, right? So u times u to the minus 1 is just 1. This is, we're doing FOIL. That's all we're doing. So plus 1u minus 2u to the minus 1, and then minus 2, right? So we get minus 1 plus 1u minus 2u to the minus 1, and now that we will take the derivative of pretty easily. So let's do it. Yu prime is the minus 1, goes away because the derivative of a constant is 0. The derivative of 1u is just 1. Minus 2, we get the derivative, we get plus 2 because the minus 1 comes down, plus u to the minus 2. Boom. Not bad, right? And actually, most of the work was kind of recognizing our old friend, quadratic, right? So don't be afraid to sort of simplify to make your derivative life easier. Yeah? So look for an opportunity to simplify. Sometimes, if I didn't see that kind of like, oh, u to the 2, u to the 2, it wouldn't have been worth it, right? Okay, tangerine going in. All right. Sorry, tangerine was good. Okay. So, same kind of thing, right? Like I'm looking for a kind of common y in both of those. There is one, and there's actually, we could rearrange those. That could be y to the minus 2, and this could be 3y to the minus 4. So I could take out a, oh, no, not plus, but minus, right? So I could take out a y to the minus 2. So let's kind of like do that. Let's simplify first before we take the derivative. So let's keep it as f to the y. And I'm going to say 1 over y squared. And the y I'm going to also take out from there, so that's going to become y over y squared, right? So I'm going to take a y squared out of this one, and then a y out of this one. Sorry, a 1 over y squared out of the first, right? So I get 1 minus 3 over y squared. And if I wasn't sure, I could multiply the y squared by those, and I would get the same thing. And out of this one, I get 1 plus 5y squared, right? And now the reason we do this is because this can cancel, so this is 1 over y times those things, right? So I'm going to kind of throw that into this one so that it can cancel the y squared one, right? So we'll get 1 minus 3 over y squared, 1 over y plus 5y, right? And if we wanted to, we could even expand this as a polynomial, but let's just actually, it might be, I mean, either way we have to do it. So let's actually just take the derivative because sometimes it's not so easy. So let's take the derivative of each. So, let's take the derivative of the product, right? So, derivative product is the derivative of the first. So minus 3 times minus 2 will become positive 6. That's a 3, even though my mind was saying 6. So positive 6. Over y to the 3. And then times this just the second as itself, right? And then plus 1 minus the original as itself, and then the derivative of the second, which is going to be negative y to the negative 2. Oh, sorry. Plus 5, right? Okay, so maybe we kind of expand this, I guess. Make it just kind of like nice and pretty. All right, so 6 over y to the 4 plus 30 over y squared plus, okay, now this one we're going to have to FOIL, and we're going to get, we have some y to the negative 2 in both. So, so let's see it. So what do we get? We get, let's do, okay, I mean, I like to multiply the exponents by, or the, sorry, variable parts by each other no matter what, right? So I'd like to do 3 over y to the 4. Minus 1 over y squared minus 15 over y squared, and then plus 5. Okay, so and those brackets now aren't doing anything for us, so let's just kind of bring everything together and see what we get. So this is 9 over y to the 4 plus, now 30 and the 15, so that's positive 15 and then minus the 1, so that's positive 14 over y squared. And then I believe it's just plus 5, right? Boom. F prime y, baby. Okay. So, not bad. We're flying. We're cruising. How we doing for time in here? Yeah. I'd like to be doing a little better, but that's okay. 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 So, let's get it 15, right? So, 15 is R of t is t plus e. Quit it with the products, bro. 3 minus, ooh, square root of t, which I don't know if we've seen, but I'm sure we can tackle it. All right, okay, let's do it. So, let's do this as a product, because either way I'm going to have to get a product. I'm going to get a product. So let's just kind of take the derivative right away. So we get 1 plus e to the t, the derivative of the first, times just the original second, and then plus the original first times the derivative of the second, which is just negative 1 over 2 times 1 over the square root of t. Okay, so this is because the square root of t is actually the same as t to the 1/2. And so when we take the derivative of that, we get 1/2 t to the negative 1/2. Right? And so this negative is just from this negative here. Okay. And now should bring these together. I mean, I guess there's probably some square roots and stuff that should come together. Actually, no. I mean, I'm just going to leave it there. Ugh, okay, no, we shouldn't, right? Okay, so let's just do it quickly. 3 plus minus root t minus e to the t root t plus, or let's say minus 1/2 square root of t minus 1/2 e to the t over the square root of t. Boom. I don't think anything can be brought together. Maybe those two can, right? So then it's just negative 3 over 2t. All right. Boom, baby. Is that right? Yeah. Okay. So that is r prime of t. Okay. So we got to see our first radical. What's radical, bro? Radical. All right, 16. Let's do it. Y is equal to t squared over 3 t squared. All right, y prime. Let's just do it. Remember, I'm going to kind of treat that like a product of two things. To the minus 1, right? So 2t, the magic of copy paste, baby. Boom. 2t times the original. Minus this thing to the minus 2, because that's the derivative of the outside, times the derivative of the inside, which is 6t minus 2, and then times the original, because we only did the derivative of the right side, but we had to keep the original, t squared. So let's just simplify. So I'm going to get t over, no, I can take a 2t. So 2t over 3t squared minus 2t plus 1. 1 minus 3t minus 1 times t. So 3t squared minus t all over 3t squared minus 2t plus 1. Woohoo! I think that's right. Because I factored a 2 out of that, and then I factored a t out of that, and then I took one of those away, so I'm only left with one on the bottom, right? Is that right? Yeah, I think so. Boom. Okay, so that's our y prime. All right, let's do it. Okay. Okay. 16. 17. Let's go. So 17. What is 17? Is t cubed plus 1 all over t to the 4 minus 2. And let's call it p of t. I think this is like a Flemish person. For some reason. Okay. So p prime of t. Let's just kind of do it quick here. Bum 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 ba ba ba. Okay, sorry, that's probably annoying. Boom, right? So that's the derivative of the outside. This negative comes from that -1, and that -2 comes from reducing that, right? So what's the highest power of t we can take out? I think we can take out t squared. We can take out basically this whole term here except for the 3, right? So t squared over t to the 4 minus 2 is going to be 3. minus 4t times t cubed plus 1 all over t to the 4 minus 2. Boom. We're going to be pros now. I don't think we need to do any more quotients, right? Let's get these GD quotients out of here. Okay. Let's do it. So let's go to, let's jump to our trig, right? We ready for it or what? I think we are, come on. There it is. All right. Let's do it. So x minus 3 sine x. So the derivative of sine is the derivative of sine. So let's, we're back to our old friend f of x. Let's make it simple, right? So what do we got? It's a story. Oh, you know what? Pull this out. All right. It's all right. Forgot something here. Okay. Let's keep plugging. So we'll take a little break at 20, but with the sine of x, the derivative of sine of x is the cos of x. Okay. Derivative of the sine of f of x, any sort of funkiness happening to the x on the inside, we just do chain rule. So we do the sine, sorry, the derivative will be the cos of that thing, right? So the sine, the derivative of the sine is cos, but then it's of the same thing, and then we have to multiply, chain rule, multiply by its derivative, right? So let's do it. Here we just have the sine of x, so that means the derivative is just cos of x. So not so bad. F prime of x, the little cousin, is just 1 minus 3 cos of x. Boom. Legologian. What a pro. Yep. Okay, let's get a little more complex here. So that was our first one with the trig. Let's keep it going. What do we got? Oh, where am I? Okay, so let's do x. Let's call this h of t. Okay, I'd say this is a Lithuanian function. X sine x, it's a product rule, right? We have to detect first the kind of outermost layer of the onion, just a product rule, right? So h prime of t is going to be 1 times sine of x, derivative of the first, times just the second itself, plus the first itself, and then times the derivative of the second. Not so bad, okay? Right? Not so bad, right? Product rule, but this trig stuff is still not so crazy. So let's get crazier here. 20. Let's do, oh gosh, what kind of poor form is this? H of t is equal to some function of x? What is that? Come on, man. Come on, man. I'm just a victim of habit, right? Let's change that. T, T, T. Thank you. Okay, I'm sure everyone knows what I mean here. Okay, so, um, 20. And thanks for stopping by the way. Legalogan. Legalogan. How would I say your name? Legalogen. Um, okay. So let's do something a little nastier here. Let's just call this one plain old y. Let's get back to our roots, okay? Sine squared x plus 10 tan of x. Yeah? And here I was being happy that that was all a constant. Yeah, exactly. Right? Okay, clearly have some math background. Okay, so y prime, so I'll maybe challenge you towards the end of this 100 derivative challenge here. Okay, but right now we're just kind of getting into um, the tans, but maybe it's been a while. I usually get people on that, right? They know the stuff, but it's been a while. So, okay, so sine squared x, this is actually sine of x squared, right? So we have to do chain rule. So 2 sine of x, and then what's the derivative of the inside? The inside is just sine of x itself, so the derivative of that is cos of x. You'll notice this is sine 2 of 2x. That's the identity, right? But let's kind of like forget about that. Plus 10, and now tan of x. Do you remember what the derivative of tan of x is? Now, if we didn't know, we could do the sine of x over the cos of x, and then treat that as if it was a weird product. So let's do it. Let's just quickly do it here. This derivative of the first is cos of x times the second, which is just this. So that's 1 plus, right? And then sorry, no, that's the original. Let's do this. I'm doing this terribly. So let's say we were taking the derivative of this, we've rewritten it as this, and now this is our kind of y prime, right? Let's say this was a new y, so let's not call it y. That one's not prime. Let's call it w, and this is w prime, right? So plus, but it's actually going to become minus because we have to do the derivative of the outside of that, right? So we hadn't done the second side of this, so we get sine of x over cos of x uh, squared. And then we still have to do the derivative of the inside. The derivative of the inside is, well, the cos is the inside derivative of cos. I don't know if we've said this yet, is negative sine of x, right? So actually our negatives cancel here. We end up with plus, and we get sine squared x, cos squared x, right? Is that right? Is that right? I feel like I did something wrong there. So we get 1 plus tan squared x. Is that right? Something went wrong there. Sine of x. Because now this will be what? Cos squared x plus sine x, sine squared x all over cos squared x. No, this is the same thing, right? So, right. 1 over cos squared x, which is just secant squared x. Right? Yeah. Okay. Okay. So let's just rearrange this. And we can now just jump to say that if if w is tan of x, w prime is secant squared of x, and you can bet your bottom dollar that your chain rule applies, right? So that's the case if this is the tan. Let's maybe get some half decent writing here. Tan of f of x is actually our function. Then our w prime will be just the secant squared is for the tan part, but we'll still have to do chain rule with our f prime multiplied on the outside. Okay, so then this is just secant square all of that to say this, yeah? Okay. So let's kind of like keep progressing. You know, I'll only do that when it's the first time that we see a certain type of derivative. So we've now seen all of the sine, the cos, and the tan. So let's do it. 21, baby. 21, baby. Okay, so let's say this one is P of R. Okay, this one here, this is from South America, I think. That's the kind of vibe I'm getting. Let's say we have 2 cos, no, let's do cosecant of R plus 5 cos of R. That one we can make R. Okay. So if you remember what cosecant is, right, be careful. So the way I remember it is sine and cosine. That just is the same thing, but with a co in front of it. So there's secant, and then there's the same thing with a co in front of it, cosecant, right? So you don't get the two cos together. It's not cosecant and cosine. It's cosecant and sine. And then it's cosine and secant, right? So what I mean by that is this is 1 over sine of x, is the cosecant of x, right? So I didn't cheat because I wrote it over here, but I know it's r, right? Okay, so then I can kind of just rewrite that when I'm doing the derivative. I don't even have to remember the cosecant of x's derivative, but you know, we will kind of prove it in this effect. So this will be the sine of, oop, slipped into it, compensail, to the -1 plus 5. Oh, careful. I'm calling that p prime. It's not p prime yet. So that, I've just rewritten it. And now when I p prime it, okay, then what do I get? I get -2 sine of r to the -2, right? And then cos of r, the derivative of the inside, plus 5 times negative sine of r. So let's just kind of simplify here. So what do we get? Negative 2 cos of r over sine squared r plus, or minus rather, 5 sine r. Okay, so maybe I would kind of start to bring those together, but who cares? If you can get that far with the calculus, you can probably get further with simplifying, right? Okay, so things are getting a little bit more complex. What was the derivative of the sine, sorry, the cosecant? It was cos of the thing, so the, um, the sort of dx of cosecant of x is cos of x over, sorry, negative cos of x over sine squared x. Okay, and then the same, of course, don't even come at me. F of x, f of x, f of x, multiplied by f prime, right? This is always our chain rule trick. Okay, so I don't like that anyway, because it usually ends up canceling or doing some things, especially when there's lots of trig functions. So I just turn them all into, I just rearrange the exponent on them. Okay, so you can do that if you want, or you can go the old school way, bro. It's a new world. All right, so let's do it. What's number 22? 22. Okay, back to the simple world. What do we have? G of t is equal to t cubed times cos of t. Okay, and this isn't so scary. So g prime of t, right? Fundamentally, we have a product, so 3t squared times cos of t plus t cubed negative sine of t, right? And now we can do some factoring and make things maybe a little bit simpler. So what can we factor out? A t, just a t squared on top, and that looks like it's kind of about it, right? So t squared 3 cos of t minus t sine of t, looks like. Okay, boom. Boom, baby. We've hit a groove. All right, let's keep it going. See if we can get to 30 before our first break. Get a little tangerine, get a little water, a little coffee. Let's do it. Okay. Okay, we haven't seen this yet, so let's do it. For secant of x plus the tan of x. Right. Okay. So secant of x is 1 over the cos of x, right, which is the cos of x to the minus 1. So when we take the derivative of that, we get minus 1 cos of x all over cos of x. Sorry. Minus 1 times minus sine of x after the chain rule, and this here is cos squared over x, right? So this is positive, this is sine x over cos squared x, right? Okay, so, and then obviously for this one it doesn't apply, but if that was an f of x function, then we would just multiply by the derivative each, right? Okay, so let's do it. So we get 4, remember what it was sine of that thing over the cos squared of that thing. And then plus, and remember this is secant squared when we take the derivative. Right? I mean, once we memorize the derivatives, it's pretty easy, right? Pretty easy. Okay, so let's kind of cruise through these trig ones. We will have some that have kind of trig combined with others. And so let's maybe do some of those. So H, oh no, I didn't draw it in black. Okay, that's okay. 24. H of theta is cosecant theta plus e to the theta cotan of theta. Okay, honestly, I'm just going to kind of rearrange these a little bit so that my life is a little easier, and then we can kind of go from there. So I'm just going to kind of keep talking about h of theta first. 1 over cosecant is 1 over sine of theta, and then plus e to the theta. And then cotan means cos over sine theta, right? So really, I can kind of like, I have a 1 over sine theta multiplied through both of them, right? Another thing we could do is also say this, right? We could do this. We could say this over tan theta. I mean, we did learn to talk about it, yes, not really that useful outside something like this, to be honest. Yeah, I mean, I would disagree. Like, you know, it depends on kind of what you're using, where you go, right? Um, but yeah, like where this is becoming more and more important is like something that I'm using it for is some quantum computing stuff. So you know, obviously it depends on kind of what field you go into. Uh, but yeah, I mean, like you kind of just memorize the rules. Like you kind of have to be at the ready to prove it at any time. But yeah, I find it just the pursuit of it also enjoyable. Okay, so yeah, I mean, we don't necessarily have to rearrange this, but if we remember, the derivative of this was negative, what was it? Negative cos x over sine squared x, right? That was the derivative. And the derivative of tan is secant squared x, right? But let's maybe just do this as a quotient, or we can do tan theta to the minus 1, right? We get minus 1 times tan of theta to the minus 2 times secant squared of theta, right? So we end up with negative secant squared theta over tan squared theta. And is secant squared theta? Secant is cosine squared, right? So 1 over, sorry, negative 1 over cos squared theta over sine squared theta over cos squared theta. And if you notice, both are over cos squared theta. So we really just have negative 1 over sine squared theta, and that is negative cosecant squared theta. Yeah. So we can kind of, you know, it makes sense too um, that we get our derivative that way. So let's say this is negative cos theta over sine squared theta, right? We said that was the derivative of that. Plus, and now I'm going to kind of write this as a product rule, right? So derivative of the first times the second plus that one itself times the derivative of that one there, right? So I think that's it. I don't think we can kind of factor anything out. No, I don't think so. There it is. H prime of theta, right? Okay, let's keep going. $25. 250. Okay, so y is e to the u times cos u plus 3u. Okay, y prime, this isn't so scary, e to the u times cos u plus 3u plus e to the u times negative sine u plus 3. Boom. Boom, baby. Okay. Not so bad. Boom, knocking them out now. 26. Okay, let's do another one here. X over cos of x. So we have a quotient rule, right? Quotient rule, I'm going to treat it like a product rule, remember? Right? And what do we get? Derivative of the first is 1 times the second as itself, featuring itself in a play about itself. Boom, boom, and then the derivative of that is negative sine of x, and then we have to keep our first the same as well. So now we can kind of factor out the 1 over cos x, and we get 1 plus sine, or let's say x sine x over cos x. Boom. Boom, baby. Okay. So we're cruising. We've seen all these types of derivatives. We've seen the quotient and everything. We will have access to the recording on the YouTube channel, where you can also find live tutoring stuff and also some other fun stuff. And we're slowly building it out. All right, let's do it. Let's say, what should we call this one? G. It's my G. 1 plus sine x all over x plus tan x. Okay, G prime. So, it's going to be ugly, but let's not make it uglier by doing quotient rule. So let's do derivative of the first, which is just cos itself, and then the second one we have to keep the same. And then minus, because of this minus here coming down, and so we get 1 plus sine x, got to keep that one the same. This is where the minus came from, and its power should go down by 1 because we just did the outside, and now let's do the inside. 1 plus secant squared of x. And now I think we can kind of, yeah, I think we can maybe factor some things out, right? Or maybe just kind of, we can factor this out, I guess. That's about it. All right, so we end up with cos of x minus 1 plus sine of x times 1 plus secant squared of x all over that ugly thing there. Just one of them because we factored one of them out. Boom. All right, we're cruising. Ugly, but we're cruising. Okay, let's do it. So, let's do, what should we call this one? Let's call it J. sine of x over 3x squared. Okay, kind of similar to the last one, so let's maybe do sine squared x. Okay, j prime. So again, the kind of trick, we're going to bring this up front, make it to the -1, right? So we get 2 sine of x times cos of x times 3x to the -2 plus, oh wait, no, that's not true. That's minus 3x squared to the -2, and then times our original top. Boom, and our negative comes out front, and the derivative of the inside, which is 6x, right? Okay, so did that probably in the horrible order, but you get the deal. So I can take out a 2 sine x, I believe, and we end up with cos of x minus 3x 3x sine x all over 3x squared, right? Okay, so then, wait, one of the x's can cancel. 3 can cancel. We get that. Beautiful. Ugly, but beautiful. Oh no, where'd my music go? That's some pump up music, baby. Where'd it go? Oh, no thank you. Sure, we'll take that. We'll take that, Capitan. Alright, J prime. There it is. Okay, let's get to 30. So that was a 27, 28. 29. Okay. Let's do it. So f of x, let's go back to the original, is cos squared x plus 1 times e to the x cos x. So this one is not one where we want to do product rule, right? Not yet, at least. So your e to the x cos x can actually get expanded, right? And then we're still dealing with a product rule though, right? In fact, we're dealing with 2 now, right? So, but either way, we're going to be dealing with 2, right? Like that itself is a product rule. So this is kind of like products on products, baby. All right, let's do it. Products on products. So, let's say f prime of x. Can we make this? I don't think we can make it any simpler, right? Or any nicer for us? No, not really. I don't think so. Okay, so what do we got? So derivative of first is 2 cos of x times negative sine of x And then that times the entire other thing. And then plus that thing by itself. So that, but now the derivative of this is its own product rule. So we have to do a product rule on just that thing itself, right? So that is e to the x times cos of x minus e to the x sine of x. And so we just have a bunch of stuff to simplify now. All right, let's do it. So negative 2 cos squared x sine of x e to the x plus cos squared x. Okay, let's just kind of expand this so that see if we can bring everything together here. So cos cubed x with an e to the x out front. Cos cubed x plus e to the x cos squared x. No, plus e to the x cos x, right? Good. And then minus e to the x sine x cos squared x minus e to the x sine of x. Okay, so I don't think I can really bring anything together, but I can factor out an e to the x. Right? So negative 2 sine x cos squared x plus cos to the 3x plus just plain old cos x minus sine x cos squared x, which we didn't have anything yet. Oh yeah, we did. Right, earlier we had that. So we can say minus 3 of those. Beautiful. And then minus sine of x. And there it is. Right? It's not too nice, but works. It's there. Okay, let's do it. One more. I'll take a little break and we'll jump back into it. All right. Last one, let's do it. So this one is a W. This one is x squared sine of x cos of x. Okay, so kind of similar to the last one, right? Okay, let's spice it up then. Let's make this cotan of x. Yeah. Okay, so let's make sure that we're not dealing with something a little simpler than we think. So remember, cotan of x, it has some sine of x on the bottom. So really, those cancel, and we get x squared, x squared times cos of x, right? So now w prime is just 2x, 2x cos of x plus x squared, minus x squared sine of x. Yeah, so we gotta be careful because that could have turned out to be way nastier. And here we are already at 30. Take a little break. Our music knows it. It's perfect. No, thank you. Okay, so what do we want to call this? Let's call it L of V. This one's beautiful, simply beautiful. 1 minus V squared all to the 10. Okay, not so bad. We just have to do chain rule, right? Am I mistaken? No. Come on. So let's do it. Chain rule. So we're going to take kind of the 10 out front. We're going to keep that thing in the inside the same. We're going to reduce that by 9. That's the outside chain rule. Now we got to do the derivative of the inside. So it's going to be negative 2v. And that's L prime v. And L prime v. Okay. So let's just kind of make it a little nicer. Negative 20v times 1 minus v squared all to the 9. Alright, not so bad. Alright. Uh-oh. File might be getting too big. It's gonna fit. Okay. There we go. 32. Ooh, this one's a nasty one. Okay, what kind of nasty? Let's go with Q. QAnon is tan of sine of x. Ooh. Okay, this is ugly. Alright. The ugliness comes from the fact that, like, we're not taking the tan of x anymore. So we get the derivative of the outside, which is secant squared of whatever is on the inside. And then the derivative of the inside, which is cos of x. Right? So the secant squared of sine of x times cos of x. Yeah, and there's no like canceling happening here because this is secant squared of the sine of x. It's not secant squared of x times sine of x. Right? Okay, so be careful of that. Okay. Not bad. Not bad actually. Right? Looks ugly, but actually it's beautiful. Alright. 33. Let's call this guy Y. Yeah, our old friend. Let's kind of introduce something a little funky. So I think we've done exponential derivatives before. I don't think we've seen a function in the exponent, right? So a function in the exponent means e to the root x kind of itself, but then the derivative, the prime of the inside, right? So what's the derivative of e to the 1/2, e to the 1/2, x to the 1/2, right? Which is really what that is. So we get 1/2 x, 1 over square root of x, I guess. That's maybe a better way to. So let's just say this is all over 2 square root of x. Yeah. That is our y prime. Okay. Sorry. I had to sneeze there for a second. Okay, let's do it. Should we go? No, let's not break convention. Okay, so 34, 34, 34, 34. 34 is y. Let's not call it y. Come on, let's call g. Sine of e to the x. Okay. So I'm going to use a kind of different notation here. I'm going to apply this thing here to kind of most of my functions, right? This is take the derivative with respect to x. So I'm going to apply that to both sides. That's how I can get away with doing this, is I'm going to apply this to both sides, and I will take the derivative of the left side, which is just now g prime, right? dg dx is just g prime, right? Uh-oh. What's that 4 doing here? No. Give it to me. Thank you. Okay. So let's actually just let's move this over here. Okay, so let's do that manipulation, but let's do it with another copy. Oh God, things are. I might have to make another file here. So that's what we're going to apply to that G, right? And that's going to be equal to when we apply it to this thing. Oh dear, this is slow, dear. Okay, there we go. Boom. So we're going to apply it to both sides, right? Okay. So that's what we've been doing this whole time. Let's kind of maybe just follow through with that a little better on this one. So we end up with, and let me just change these to be purple to kind of keep the notation. Come on now. Thank you. Okay. So we say G prime is equal to now the sine, the derivative of the sine of e to the x is we're actually going to take the derivative there. So we end up with cos of e to the x. And then the d kind of gets transferred to the e to the x, the inside, right? So when you take the derivative, you just transfer your d dx to the next layer, right? So we took the derivative of the sine part, and that's what we got. And now that's the derivative of the inside here. And what is the derivative of the inside? It is just e to the x itself. So this whole thing becomes cos of e to the x times e to the x, right? And generally, so that there's no confusion, we put that out front. So we'll write it this way. Okay. Okay. So that's how we can sort of use chain rule, right? And then what's really here is the inside with the last inside, which is this inside, and it's dx dx, which is just 1, right? So that's where that goes in a sense. Dx dx is just 1. Whether you want to think of that as something over itself is always 1, or, you know, the derivative of x is just 1, that's up to you, right? Those are both true. Okay, so beautiful. Okay, so we can use that whenever we want, but let's just kind of keep going. It looks like we're going to dive into sort of using chain rule, using everything into chain rule. So let's do it. So let's say z is equal to x e to the minus x squared. Okay, so again, differentiate, right? Okay, what do we get? Well, we have a product, right? So z prime is equal to 1 e to the minus x squared plus x, and now whatever the e to the function is, you just put the e to the function again, and then you do the derivative of the inside, which is just negative 2x, right? So it looks like we have this in both of them, right? And it's 1 minus 2x squared. Is that right? It looks like that's right. Okay. So we could kind of, if we wanted to, we could rewrite this as over e to the x squared. Right? So that means beautiful. Okay, that's 35. We're already cruising. 40 down. Let's get to 40. All we need to do. Let's get to 40. Okay. So what do we have? What's the next one? Let's call it W. It's e to the negative 5t cos of 3t. Okay. So what do we got here? W prime. W prime, baby. W prime. This is a product fundamentally just on this outermost layer of this onion. The skin of the onion, it says product. Okay. So we got to do e to the negative 5t. This is the derivative of the first. No, sorry, the t is gone. Times just the plain old second plus the plain old first times the derivative of the second times the derivative of the inside of the second. Right? Don't forget that 3. And so what do we get? We're going to e to the negative 5t of front. We're going to negative 5 cos of 3t minus, so let's just take a minus out front. We can make this a 5 cos t plus 3 sine 3t. Is that right? I think that's right. Come on now. I think it's right. Okay. So when we get to 40, I think we might have to make this a different file. Okay. Yeah, this thing. She's slowing. All right. Just give me 1 second here, actually. All right, let's see if that's any better. 30cx. Okay, let's do it. 37. Let's pull it up. Pull it up. Okay, what should we go for? Let's go for an N. Okay. So that cos x is in the exponent here, right? So we're gonna have to do e to the, oh, let's not do it in black. Let's do it in another. So n prime, or first thing we're gonna do is just itself, but then the derivative of the function in the exponent, right? The derivative of the inside. So the derivative of the inside here is a product. So let's do derivative of the first, right? Is 1, and then just the second, and then the original first, and then the derivative of the second. And so what do we get? And this is multiplied out front, right? Not in the exponent. So I think, yeah, I mean, things could kind of get a tiny bit simpler. Let's just kind of erase the 1, and let's just say minus x sine x. Boom. Not bad. Sketty. Sketty spaghetti. Right. So 38. J is square root z minus 1 all over z plus 1. Right? Okay. So the square root of the whole thing. So that's going to be a whole sort of chain rule on the outside. Right? So that is a 1/2 that will come out front of the outside. And then here we'll still have our z minus 1 and our z plus 1. But it will now be to the negative 1/2. Right? Because this was to 1/2, and then we subtracted 1, which is negative 1/2. Oop. Okay. And then we have to take the derivative of the inside, and this is where our kind of quotient rule might come in handy here, right? So it's, what is it? Derivative of the first times the bottom minus the derivative of the second, right? The bottom, which is just this, and then times the top all over the bottom squared. So we can kind of simplify that. J prime. J prime is z plus 1 minus z minus 1. So really we have to distribute the minus there, right? So we end up with 1 plus 1, which is 2. So we end up with 2 over 2, right? Which will cancel. And we'll end up with a 1 over z plus 1 squared. And we'll end up with a z minus 1 over z plus 1 to the negative 1/2. Right? Or if you wanted to think of it, you could actually flip those two and make this a positive 1/2, which is the same as the square root. Boom. Okay. Sorry about that. All right, 39. Let's tackle it. So we've got, let's call this one, I don't know, I'm kind of feeling a W. I don't know. Just screaming out to me. E to the 2u over e to the u plus e to the negative u. Okay, so outermost layer of the onion, we see a quotient, right? So we're going to have to do quotient rule first, but let's not do it as a quotient rule. Let's actually kind of cheat and turn it into our product rule, right? Oh yeah, after this one, I have to start a new file because this file is getting a little tired. Okay, so that one to the minus 1, right? So W prime, let's do it, product rule. So e to the 2u, keep the same function every exponential to a function, and then just take the derivative of the inside on the top there. Let's keep our second the same. And then with the product rule, we end up with this to the -2. That's where that minus came from, because it's supposed to be plus, but because it's -1 coming down in that derivative, we end up with a minus. And now we have to take the derivative of the inside, which is just e to the u minus e to the u. Sorry, e to the minus u, right? Okay, and then careful because we have to make sure that we also incorporated the first one untouched in that second one when we did product rule, right? Okay, so we can factor out e to the 2u over e to u plus e to the minus u. And what do we get? 2 minus e to the u minus e to the minus u all over e to the u plus e to the minus u, right? Looks like some sort of, kind of arctan stuff, right? Boom. W prime. W prime. Okay. So look at how slow that is. So much lag. Gonna need to get that under control. Way to do that is, I already tried to open and close the program, but she's not working. So we're gonna have to start a new file. That's fine. Let's do it. 40. So, boom, 40. Let's do, what should we call this one? Let's call this one's a J of T. So this is a JIT. So then we should use T over square root of T squared plus 1. Yeah. So quotient rule, let's kind of do it. J prime of T is, let's do it as a T times the square root of T squared plus 1 to the -1. And so what do we get? Derivative of the first times the untouched, times the untouched second one. Boom, boom. And then this always becomes minus, so I put a minus here. It's because this -1 is going to kind of come down when we take the derivative of it in our second term. So let's just kind of do that right away. We end up with negative, and it doesn't matter that I kind of haven't incorporated the square root function, right? Some of you might be saying, oh, well, what about the square root function? We'll do that when we get there. That's another layer of the onion, right? So we get this plus 1 to the -2, and now the derivative of the inside there, right? It's our job to do the derivative of the inside. Okay, so we have to multiply by the derivative of the inside. We also have to multiply by the untouched, original t, right? Which is our numerator. Yeah. Okay, so then we get minus t, sorry, we get derivative of the inside, which is, this is a, kind of a strange way to represent this, but this is just showing that we can do it this way, right? We're going to bring the 1/2 down. We end up with t squared plus 1 to the -1/2, right? And then the derivative of that inside is 2t, and the derivative of that inside is just 1, so we'll leave it, right? Okay, so all these kind of things can kind of be like combined, right? So let's simplify this a little bit. This is to the 1/2. So those two can combine to be -1. Right? And now that's to the -3 over 2. Right? And this is really just negative 1 over 2. Okay, so we end up with what? We can kind of factor that out. Right, this is kind of the simplification that we've been doing. And we end up with 1 minus, and we will end up with that whole thing on the top, because when we take this, when we take this out of that, we end up with a whole. Right? Okay. So on top, then, what do we end up with? Just t squared, I believe, right? Because that 2 cancels with that 2. Yeah. So we get t squared all over t squared plus 1 to the 1. Beautiful. Okay. We could obviously like make that simpler there too. So let's maybe even do that. Let's say that's t squared plus 1 minus t squared all over t squared plus 1, which is the same thing as 1 over that thing, right? So, well, let's do this. Let's not do that. Boom. Okay, boom. 1 over the square root, so I'm just going to do this. T squared plus 1 to the 1/2 times that. And so that could be 1 over. So the whole thing is, boom. That ended up looking pretty nice. Okay. Don't think I screwed up anything there. Just look at coefficients. I think we're good. Okay, so I'm just going to rearrange this a bit. I'm going to open a new file here. I don't think that we have to worry about that. That was something else. I think we're cool, right? Okay, not bad. First 40. First 40 out of the way. We are 2/5 of the way. We're 40% of the way, sir. Okay, not bad. So let's keep it moving. We'll keep it cruising. Okay, I'm just going to take a 2-minute here. I need a little drink of water. I'm going to have a little tangerine, and I will be back for the next 60. We'll go back. So, okay, so H prime. This is a quotient, right? So let's do this. We can do this one as a quotient rule if you want. So 2 sine of x cos of x times cos of x minus sine squared x negative sine x all over cos squared x, right? So this is really plus sine cubed, so let's maybe just not do it like that. Let's just use the old magic of the copy paste. So this is plus cubed, and we can incorporate that, and then this is cos squared x, and we could maybe factor a sine out of this, right? But I don't really see the use. We're done, right? Boom. So a lot of this, like the actual calculus is one line, and then the rest is simplification. Okay, let's do it. 42. 42 is going to be, okay, so let's kind of just redo that one. What did we call it before? What should we call it now? I'm feeling a D. So d of b is tan of, I don't even remember what it was, so let's just do this. Tan of sine of b. So the outside is the tan part. And the d here is kind of confusing, so let's actually not use d. Let's call that p of b. Okay, so p of b. So I'm going to do now p prime of b is equal to, well, secant squared of that thing, but then that thing's derivative is cos of b, right? And it doesn't really get simpler than that. It don't get simpler than that, right? Boom. Okay. Let's do our next one here. 43. Let's do it. Okay, so let's call this one v of u, and it's equal to 2 to the power of sine of pi u. That's the exponent there. Okay, so I don't know if we've seen one like this. We've maybe seen like e to the x kind of just becomes e to the x, right? And e to the f of x becomes e to the f of x times f prime of x, right? That's just chain rule. We've seen that. That's e to the x is kind of like this one, but this one, the base is an e, right? So what's actually hidden here is the ln of e, right? So the value here, or the derivative of basically b to the x, the derivative of that, if that is y, then y prime is b to the x times the ln of b. Yeah. And if this is a function, if this is an f of x, then this is the f of x and it's ln b, and then you have f prime of x. Okay, so the ln b is kind of just like a coefficient that shows up. Okay. So be careful of our base, right? If it's e, we don't have to do that ln e because ln e is 1, but otherwise ln of the base is important. Okay. So okay, let's do it. So v prime of u, we also have kind of chain rule to do. So it's going to be 2 to the something ln 2, that's the ln of the base, but then the derivative, so what we're doing is kind of like this one. We now have to do the f prime, and the f prime is sine pi u. So the f prime of that is cos pi u, and then times an extra pi from the pi u. Yeah. So I don't think this really gets any nicer, but that's our derivative. Okay. So that's our first time seeing that kind of like 2 to the power of something. We've seen e to the power of something, but not 2 to the power of something. Okay. These are moving a lot smoother. A lot easier. All right. All right. That's good. Okay, let's do it. So let's call this one a Z. Uh-oh. We're going Imperial. On my air. All right. So we have to do the tan squared. We have to do the squared first. So remember, tan on the inside there isn't really going to get touched when we do the outside first, but then we have to do the derivative of the inside, and then we get secant squared of 3 prime. And then we have to do the inside of that, which is 3. Okay, so secant squared can combine with tan. How? Secant is one of our cos, right? So this is 6 sine 3 theta over, or secant cubed 3 theta. Right? Alright, get that black out of there. Okay. Gotta maintain format. Okay. We're at 44. We're cruising through these. 45. Okay, this one's a W. W of Z. It's a Wheels kit. 1 plus cos squared of Z. 6. And I lose on my air here. Right? So the 6 comes out front, and we get 1 plus cos squared Z to the power of 5, and then 1, the derivative of the inside is another chain rule, right? And then the derivative of the inside of that is the cos of Z, and so that's negative sine of Z, and then the derivative of the inside is Z, and derivative of Z is 1. So now we're okay. So, what do we get? I feel, okay, so 12, negative 12. 1 plus cos squared Z. So my air. Is that right? Yeah. Right? Or we could also even just turn all of that. We could say this is negative 6 sine 2Z. Right? Because of that identity. Whatever you wanted to do. Okay? Boom, 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 boom. Boom, 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 boom. Boom, boom, boom. Man, I'm losing all my air. Right, 46. Let's keep chugging. Right. God damn it. What else are you good for? I think is the right of with null and I. Typewriter. All right. Let's do we. So let's do this one's called C of X. Excuse me. Who are you talking to right now? Jeez. Harsh. Okay. What is this? Sure. Sure. Hit me with it. Hit me with it. Hit me with it. Come on now. You. I knew it. Something weird. Something weird was coming. All right. Okay. C prime of X. Let's do it. So derivative of the first, and then just keep the second, plus the original first, but then the derivative of the second, so it's going to be cos of whatever is there, and then the derivative of whatever is there, which is negative 1 over x to the 2. Right? Okay. I don't think this gets any nicer. We could kind of simplify that, right? So let's just do that. Boom. Yeah? Okay. And we can't really bring that together, right? Nice. Okay. All right. Let's keep it going. That's 46. All right. Okay. So let's call this, what should we call this? Let's call this K of L. Keel. 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 All right, K prime keel. K prime eel is what? Secant squared L. So remember that the derivative of secant squared is sine of x over cos squared of x squared of x, right? So that's just sine of secant of x, right? Is that right? Let's not speak out of turn here. Yeah. Okay, so then let's do the outside first. And then the derivative of the inside is that, right? And so remember secant of L is 1 over cos, right? So that's now can be turned into secant cubed of L, right? So, but let's not do that yet. Plus, and now the same thing here, we have to do the derivative of the outside first, and then we do the derivative of the inside, and we get secant squared of L, right? So let's just kind of simplify and maybe factor if we can. So I think we can factor the 2 secant squared of L. Because remember, this represents a secant squared, right? So what do we end up with? Tan of x plus tan of x, right? 2 tan of x. So actually, let's not stop doing that. Okay, so 4 secant squared of L tan of x. Boom. Okay, nice. That simplified nice. Right. Okay, let's keep it going. Okay, 48. Give it to me. Give it to me, baby. I didn't start a podcast. I haven't started a podcast. Stop. Stop. Stop it. I need a dance mix. You think? What do we think? A dance mix. Should I just risk it? Google dance mix. Ooh, I love it. Already love it. Ooh, okay. Hmm. A little high energy. That's all right. Let's do it. Okay. So I'm gonna need to slow down enough to dance here. Okay, now let's be cheeky and do L of K. Cheeky, cheeky. Mm, 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 mm. Okay, so e to the k tan of square root of k. Real mobile now. Okay, let's do it. Let's make that a little smaller. We'll do this one. Okay, so this is all in the exponent, so we're gonna have to do just L prime of k is e to just itself, and then the derivative of the inside here is going to be a product where we do derivative of the first one first, and the second one we keep the k, and now we do derivative of tan square root of x. Derivative of tan square root of x is secant squared square root of x, or k, sorry. And then we have to do the derivative, the square root of k, which is 1/2 1 over square root of k. All right? Okay, so let's just kind of simplify things here a little bit. So e to the k tan of square root of, why is that x showing up? Okay, okay, oh god, why am I tan so ugly? I don't look good with a tan. I don't get spray tanned anymore, I used to. Okay, so tan square root of x plus square root of k over 2 times secant square root of square root of k. Boom, boom, baby, boom, baby, boom, boom. That's right. Right. Okay. Let's keep going. So that's an ugly chain rule, right? But not impossible. Okay. Not bad. Let's do it. So when we get to 40, when we get to 50, we will do our push-ups. Oh yeah. Oh yeah. The knife. Uh, Alright, we're getting there. Just getting a little counter up. Actually, I think we're okay without these. Yeah, I don't think we need the counter, right? Do we need that? Let's get to 49. Let's get to 49, baby. Ooh, things are getting a little hot and heavy here in this party. this club. Okay. And then you announce the DJ and you switch it totally. Feel like I'm drowning. Alright, this one feels like a... This one feels like an F to me, actually. We haven't had an F in a while. It's not an F of X, it's an F of J. Cotan squared of sine of J. Sine that J. Okay, so... okay, so cotan. So derivative of cotan. But we don't even have to do the derivative of cotan yet, because the outermost shell of this onion is, we can kind of rewrite this as layers of the onion. So as we go from the outside in, we're going to hit the squared first. We have to take the derivative of that. Then we hit this cotan thing. Then we hit the sine thing. Then we hit the j thing. Right? So we'll have to do it in that order. So first we have 2 cotan of sine of j, right? And then the derivative of the inside. And what is the derivative of cotan? It is negative cosecant squared of that thing. And then the derivative of the inside of that thing, which is cos of j, and the derivative of the inside of that, j, which is 0, right? So let's get all this in green, actually. Boom. So time to simplify. This is all just kind of like, multiplied together, right? So I don't think anything really gets nicer here. I guess cosecant is 1 over sine, right? So, okay, so that will kind of combine with the cotan, right? I guess. So 2 cos of sine of j, sorry, negative over, or really just multiplied by cosecant cubed of sine of j. Incorporate that negative there, and then we just have the cos of j. I think that's right. Boom, baby. Okay, yeah, pretty complex, right? But we can get there. We can do it. All right, let's do it. 50. Let's do it. Oh my god. Vindictive. Okay, so let's say B of W, BW is sine of x squared. Okay. All right. So let's do it. B prime of W. 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 Boom. Okay. So this is the cos of that thing times the derivative of the inside, which is the cos of that thing, times the derivative of the inside of that, which is the cos of that thing, times the derivative of the inside of that, which is 2w. Right? So let's do it. What do we get? I don't think anything really kind of like simplifies here, actually. So we would just kind of write it like this. Oh, boom. Okay. So it's kind of ugly, but they actually aren't that complex in terms of derivatives, right? But it is chain rule stuff. Okay. So that's 50. Okay, so it's push-up time.